Hello, statistics students. Here's a video on comparing proportions from two populations, changes to ingredients, checking conditions. Example 2, this is an example where we're going to go through the full hypothesis tests. So let's read the problem. We're talking about environmental quality. A Gallup poll asked random samples of Americans in 2016 and 2018 if they were satisfied with the quality of the environment. In 2016, 543 were satisfied with the quality of the environment and 440 were dissatisfied. In 2018, 461 were satisfied and 532 were dissatisfied. Determine whether the proportion of Americans who are satisfied with the quality of the environment has declined. Use a 0.05 significance level. So as I read through this problem, I see we're taking samples of Americans in 2018 and samples of Americans 2018 and seeing if they were satisfied with the quality of the environment. So I can see here that our population is going to be the Americans in 2016 and the Americans in 2018. Those are the populations that we are working with. Okay, so it's two different populations. Population Americans in 2016 and population Americans in 2018. Okay, so we'll go through the full hypothesis test to determine if the quality environment, to determine if the proportion of Americans who are satisfied with the quality environment has declined. So remember, this is a four-step process. So the first one is the hypotheses. Define your parameters and set up the hypotheses. Step 2, prepare. So we're going to choose a test statistic, and then we'll check the conditions. 3, compute to prepare. State a significance level. That's been stated for us. And compute the observed value of the test statistic. Then find the test statistic because it compares our observed value with the null. Fourth one, interpret. Compare it to the significance, compare your p-value to the significance level to see if we have significant evidence to reject the null, or if we don't have significant evidence, then we fail to reject the null, remembering that we never accept the null, we only fail to reject it. Okay, number 1, hypotheses. So in order to form the hypotheses, remember the hypotheses works with the population parameters. So what are our population parameters? So we said the first population is the population of Americans in 2016. We're asking them if they're satisfied with the quality of the environment. So the population parameter P1 is going to be the proportion of those Americans in 2016 who say they're satisfied with the quality of the environment. So group 1 is 2016. Group 2 is 2018. So the population parameter P2 is going to be the population or true proportion of Americans in 2018 who say they're satisfied with the quality of the environment. Now that we have our parameters defined for us, the null hypothesis is always a status quo, nothing has changed. The alternative hypothesis, we were asked to determine whether the proportion of Americans are satisfied with the quality of the environment has declined over the years. So that would mean that the true population proportion of those who say they're satisfied with the quality environment in 2016 would be greater than those who say that in 2018. Now, some people will label these as P 2016 and P 2018. That's perfectly fine. In fact, that's a little more descriptive. Okay, we have our hypotheses set up. Now, number two, we want to prepare. We want to choose a test statistic and check the conditions. So the test statistic that we choose is a 2 proportion. Some people will abbreviate that as PROP. It's a 2 proportion, and since these are proportions, we call these z-tests. 2 proportion z-test. And so now we need to check the conditions. And so remember, there's 4 conditions to check. The first one is that we have large samples. And that is the number of successes and number of failures, or at least 10. But this is where the change has come about because we don't know the difference. Because the null says that P1 and P2 are the same. So we use the pooled proportion to find successes and failures. And remember, P hat is putting the 2 samples together. So we go back up here and it says that in 2016, 543 were satisfied and 440 were dissatisfied. And it said in 2018, 461 were satisfied and 532 were dissatisfied. So then that means in 2016, that's satisfied, dissatisfied, there was 983 people in the sample in 2016. And there were 993 people in the sample in 2018. So that means that our P1 hat is 543 satisfied out of the 983 for 2016 in the sample. In the sample for 2018, 461 were satisfied out of 993. The pooled proportion says, make it like it's one big sample of those who said they were satisfied divided by all of the people in the 2 samples. And so we add those up and divide, which gives a total yeses of 1,004, or satisfied 1,004 out of 1976. So we go 1,004 divided by 1976. And that gives us a pooled proportion of about 0.508. Okay, now we check the number of successes in 2016 and the number of failures in 2016, and the same thing for 2018. So now we're going to check the following conditions. N1 P hat, N1 1 minus P hat. So N1 is 983 times 0.508. 983 times 0.5 is half of 983. These are definitely bigger than 10. N1 is 983 times 1 minus 0.508. That's going to be just roughly smaller than a half. So this is definitely bigger than or equal to 10. In 2018, there was 993 times the pooled proportion of 508. This is obviously bigger and equal to 10. And 993 times 1 minus 0.508 is obviously bigger than equal to 10. So we have large enough samples. Number 2 says that the samples need to be chosen randomly. If this is not stated in the problem, then we just make that assumption and say proceed with caution. And this one said that a Gallup poll asked random samples of Americans. And so we will say that random, it said it was random. Check. 3, independent samples. This is one that we typically assume is true unless it's obvious that they're dependent, meaning people are in the same sample. But if we're sampling Americans in 2016 and Americans in 2018, we should assume that nobody is going to be put in this sample twice, making it independent. So we'll assume independence. Three means independent with, 4 is independent within the samples. And so these observations must be independent of one another. So let's say we're in the sample of 2016, it's logical to assume that when one person says that they were satisfied with the environment, the quality of the environment, that's not going to sway the next person what they say about the quality of environment. So we'll assume that these people didn't hear the other people's outcomes. So we'll assume that these observations are independent. If not, then our result might be less accurate than we thought. Okay, so step 2, prepare. Step 3, compute to prepare. We've stated our significance level of 0.05. We're stating that there's a 5% chance that we could reject the null when it is actually true. We wanted to make that as small as possible, so that's why we chose 0.05. We want to compute the observed value. And these are our samples. Because we're choosing the first group to be 2016, our P1 hat is 543 divided by 983. And 2018 is our group 2. P2 hat is 461 divided by 993. Okay, those are from the samples. We do need to estimate what these are. So the observed value, because we're doing P1 is greater than P2, we'll think of this as P1 minus P2 is greater than 0. So our observed value is going to be P1 hat minus P2 hat. (543) divided by 983 minus 461 divided by 993. put that into our calculator. $543 divided by 983 minus 461 divided by 993. That is 0.088. That's our observed value. Now, we need to compare that to the null, how many standard errors away that is from the null. So now we need our test statistic. We said that we're going to be choosing a 2 proportion Z test statistic. We take the observed value, 0.088, subtract off the null value, 0, and divide that by the standard error. Almost always the null is 0. So this just turns into observed value minus divided by the standard error. So we have 0.088 divided by our standard error. Remember, our standard error is given by p hat times 1 minus p hat times 1 over n1 plus 1 over n2 and the square root of that. So I'm going to show you how to do this all by hand, and then I'll also show you how to do it in StatCrunch. So now we need the standard error. We said this pooled proportion p hat is 0.508. We got 983 and 993. Okay, we'll put that onto our calculator and we'll estimate the standard error, which will give us our Z statistic. So typing in 0.508 times 1 minus 0.508 times 1 over 983 plus 1 over 993 and the square root of all that gives us about 0.022. Now do keep in mind, these are estimates. So we are making a bunch of estimates here, which when plugging back into other formulas could make further errors. And in this case, 0.088 divided by 0.022 is exactly 4. So we know from experience that when you're 4 standard errors away from something, it's very unlikely that that sort of thing happens. So we can find the p-value associated with a test statistic of 4, noting that we are doing a right-tailed test. We're going to be looking to the right and finding the probability that we would obtain a test statistic as big as 4 or something more than that. We're going to expect a very small probability because we know once you start getting outside of the 2s, it's really small probability. So we use StatCrunch to find this p-value. And then, like I said, I'll use StatCrunch to do the entire hypothesis test as well. Okay. So we want the normal distribution. Stat calculator, normal distribution, and we want to know the probability that will be greater than or equal to 4 on the standard normal curve. Remember, we checked the conditions, so our test statistics are normally distributed, and the probability that we get bigger and equal to 4 is 0.00. I can't even see how many zeros it is. 1, 2, 3, 4 zeros. So that says that our p-value is pretty much 0. Between 0.0003167, which is well less than our significance level of 0.05. So we reject the null in favor of the alternative hypothesis. So we'll go ahead and conclude in context of the problem what this means, but I also want to show you how we would do this full hypothesis test in StatCrunch rather than showing these calculations, rather than doing these calculations by hand. Okay, so let's go ahead and get rid of this. And remember, we're doing a 2 proportion z-test. So proportion stats, we're doing proportion to sample with summary. We have to go back up here and get our proportions again. And putting those numbers into StatCrunch. Okay, number of successes for population 1 is 543. Number of observations, number of people in that sample, 983. Successes in population 2, 461. Number of people in that sample, 993. We're doing a right-tailed hypothesis test. So we're trying to test if P1 minus P2 is greater than 0 or P1 is greater than P2. I'm going to show a p-value of that plot, and we'll go ahead and compute that. Let's go ahead and copy that so that we can compare with what we saw before. Okay, so from StatCrunch, we see that our test statistic is 3.9185. I cut that off, didn't I? And the p-value says less than 0.0001. So it doesn't tell us what our p-value is, but it does say that it's so small that it's less than 0.0001. So again, we reject the null because the p-value is less than the significance level. So same result, but notice we had a test statistic of 4 by the calculations because we were rounding, and the StatCrunch uses more precise values, giving us 3.919. But they're both really far away from what the null says that we should have. Okay, step 4. Interpret. So since the p-value is less than 0.05, we have sufficient evidence to support the claim we were trying to test. Whether the proportion of Americans who are satisfied with the quality of environment has declined. So we set up our population parameters, the population proportion of Americans in 2016 who say they're satisfied with the quality of the environment, P1, and P2 is the proportion of Americans in 2018 who say they're satisfied with the quality of the environment. We've just shown that it's declined, that P1 is greater than P2. So I'm going to use those statements where I've defined those parameters. So I'm going to go out and grab those and write that down. Sufficient evidence to support the claim that the population, or the true proportion of Americans in 2016 who say they are satisfied with the quality of environment, has declined, or I should say is greater than the population, or the true proportion of Americans in 2018 who say they're satisfied with the quality of environment. And that's how we state that in context. We've rejected the null in favor of the alternative, so we know that the proportions have declined over time, and so we write it in terms of what was stated. Proportion of Americans in 2016 who say they're satisfied with the quality environment is greater than the population. Proportion of Americans in 2018 who say they're satisfied with the quality of the environment. It's declined. And this concludes the video on comparing two population proportions, changes to ingredients, checking conditions, and the example 2.